Hey everybody, this is Larry. This is me going over day 27 of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, ask me questions, and usually I self and explain these live, so if it goes a little slow, just go fast forward through it, because I like to go through my thought process, not just the solution. Okay, so today's problem is jump game 4. Given an array, first index of the array. Okay, so you could go. Okay, so I'm just trying to look at the variation. So this is I plus 1, I minus 1, and then you get like a free travel to whatever. Okay, and where do you start? Oh, the first index and the last. Okay. So that seems okay. Let me look at the constraints. Constraints are 5 times 10 to the 4th. Should be okay. Okay, so my immediate thought is just breadth first search. Because basically you can think about it as a graph problem where or I think about it kind of in a weird way, like a bus problem or something like that, because well, you could go left, you could go right. I think that's straightforward. The only other thing to kind of notice is that you can go from a number to another number or another index with the same number, so that makes it easier as well. The only thing that I have to make sure and have concerns about is try to make sure that we don't you just try to figure out how to represent the edges in a good way. Because if I were to do it very naively, right, like here, for example, we put all the 7 to connect all the 7 in terms of edges, but then you might, this becomes in a worst case scenario, in a degenerate case, let's say they're all ones or something like that, then it becomes n squared in a weird way, right? So you have to be really careful about how to do it. And I think the way that I would think about it is maybe just that once you use up a number, you can't, like if you take in the bus, you can't take it again. I think the reason why that is the case is because if you take the same bus, I say the same bus, but if you use the same number to travel, right? If you take it again later, that means that the first time you should have got off at a later. I keep on saying bus line because of the bus number or whatever. But yeah, that means that you should have gotten to an index that's closer. So with that in mind, I think that's enough for it to be breadth first searchable. Because now that means that each number will be only accessed constant number of times, and that means that this algorithm is going to be linear. Okay, let's start encoding. Oh, I C# on because during the contest I had to write something in C# to make it faster earlier today. I didn't do that well in that contest. I did win another contest earlier though, so maybe it averages out a little bit. But yeah. Okay, so anyway, back to main topic. Python, let's go. So let's just say well, let's pre-process them all together. So now I'm going to keep on calling them buses because I just think about them as bus lines for some reason. It might not make sense to you, so use your own variable names that are more reasonable. But okay, so n is equal to length of r. And then now for so now let's just say, scene. I just call it basically the numbers that you use and don't use anymore, the bus lines if you want to call it that, and then also just something that maps the bus line to all the bus stops if you want to call it that. So then now for x is an array of let's call index x in enumerate array, stops of x append index, right? Okay, So then that's basically all we have to do to start off the breadth first search. So the breadth first search, we start with a queue, collections.deck. We want to append. We have to do the minimum of moves. Okay, I just forgot whether it was Boolean or something like that, but that's fine. Yeah, and then let's also keep track of the distance for each thing. I don't actually strictly think this is necessary, but I'm going to do it this way. Yeah, equals 2. Let's just say infinity times n, where infinity is just some big number, right? And then now we can set the first element as 0 because this is where we start. We append index 0, right? And that's good enough for us, I think. Yeah. Okay, I just thinking through whether I need anything more. But yeah, so while length is equal to q, you know, current is equal to q.pop left. So basically we're processing this number. If current is equal to n minus 1, then we return d of current, which is where we store the distance. And then now we go left and the right. So for let's just say I usually call it next, but next is obviously a keyword. So so I use something like that, which is kind of awkward looking. But anyway, in let's see, current minus 1, current plus 1. Yeah, and then now we just have to check that it is next, you know, inside the array. If it's inside the array, then that's let's also check that, and d of the current plus 1 is less than d of nxt. That means that this way will let us go there faster. Though we're doing breadth first search, so you could also have just use, like, it's very binary, right? Once you relax it, it should be the quickest way to get there. But once, if this is the case, well, we set this to you go to current plus 1, and we also want to append this to the thing. And then we do the same thing for maybe another way to write it is, okay, so candidates is equal to current plus 1, current plus 1, right? So in order to not duplicate the code too much, we can also put all the stops in there. So that means if, let's see, array of current is the current bus number. I keep calling it buses. So, so if this is not in scene, then that means that we haven't taken this bus yet, as we said. So we want to add this to the buses we've seen, and then we also want to add all the bus stops in it, right? So candidates do stops up current. And I think this should be enough. And then if it's impossible, we return -1 or something. Huh? Is it always possible? Oh, it's always possible because you can always go +1 -1. Okay. Duh. So let's give it a go. Ooh, wrong answer though. Maybe that's the story of my evening. Very tired. I should have slept more. That's my excuse. I'm sticking to it. But so how it is wrong will allow me to kind of figure out why it is wrong, hopefully. This is good. Let's see. Let's print it out real quick. That is a little. Did not really expect this, but so yeah, 0 goes to 0. So okay. So the candidates looks like it is not really working. Let's see. That's a little bit weird. Did I mess this up? Let's print out all the stuff in general, because that doesn't make sense. Because for each number in an array, we just yeah, this looks more what I expect, but oh, I am, because current is the index, but the actual thing is array subcurrent. Okay, me is being dumb after all. Alright. Knew it was something silly, but I need more sleep. It's a little bit late. It's 3:30. That's my excuse, and I'm sticking to it. And I didn't sleep that much yesterday because of the contests. But yeah, okay, cool. Yeah, so there's no impossible because you can always just go I+1. So at the worst case, it's gonna be O of n. But yeah, in terms of complexity, this is gonna be linear time because for each node, for each index, for each bus stop, you're going to only process it once, and there are only two ways you can, like for this loop, it only even happens like 2-3 times, right? Because you can either reach a node from the left or a node from the right, or took a bus to get there. So for the most part, like this only happens once for each node, and so like everything is linear time. And n is equal to 5 times 10 to the 4th. That's a great idea. In terms of space, it's going to be linear as well because we have use a queue and also this distant array thing. Though I guess technically you could have stored it on the queue, but it's the same thing as you can imagine. And a dictionary to kind of help us out a little bit, just for easier mapping. But yeah, let me know what you think about this problem. I'm a little bit tired, so I don't know how to explain stuff, but I'll see you tomorrow. Hope you have a great, rest of the weekend. Bye-bye.